The question says, what volume of 0.5 mole per dm cube tetrazosulfate acid will exactly neutralize 20 centimeter cube of 0.1 mole per dm cube sodium hydroxide solution? The first thing to do here is to write out the chemical equation. And there we have acid reacting with the base, which is a neutralization reaction. And in neutralization reaction, we have acid reacting with base to give us salt and water. So let's write the equation. The acid H2SO4 reacting with the base sodium hydroxide to give the salt sodium sulfate and water. So after writing the chemical equation, the next thing is to see if the equation is balanced, because without a balanced chemical equation we'll be having a wrong value. So let's check. Let's start with sodium. We have one atom of sodium present here, and here we have 2. So let's add 2 here to balance that. So now we have 2 atoms of sodium on both sides. Oxygen now, this 2 is also affecting oxygen and hydrogen as well. So we have 2 times 1 here, that's 2. So 2 plus 4 gives us 6. We have 6 atoms of oxygen in the reactant side. And in the product side, we have 4 plus 1, that's 5. So we need to make this 6. So let's add 2 here as well. So now we have 4 plus 2, that's 6. So 6 on the product side and 6 in the reactant side. That's for oxygen. Let's check hydrogen. Hydrogen here we have 2 plus 2, that's 4 in the reactant side. In the product side, we have 2 times 2, which makes it 4. So we have 4 atoms of hydrogen on both sides. And then sulfur, the last atom we'll be checking for. We have 1 atom present in the reactant side. And in the product side, we have 1 atom of sulfur present as well. Having done this, the next thing to do is to proceed with the calculation. And in any question that has to do with neutralization or volumetric analysis, which we also know as titration, wherein we have been given the acid and the base. We have the concentrations of the acid and the volume of the acid and base respectively. The formula we'll be using in most cases, and also in a case like this, is CAVA divided by CBVB, which is equal to Na over Nb. This Na divided by Nb can also be regarded to as mole ratio. So Na is the number of moles of the acid and Nb is the number of the moles of the base. While Ca is the concentration of the acid, Va is the volume of the acid, Cb is the concentration of the base, Vb is the volume of the base, while Na and Nb, as earlier said, is the number of moles of the acid and the base respectively. After writing the formula, the next thing to do is to write out the values given from the question. We'll be doing this to make it easier for us to find the unknown. So here we have Ca to be 0.5 mole per dm cube. And Va is unknown. Then Na, and is the number of moles of the acid, which will be gotten from the equation, and that's the coefficient in front of the acid. Here the coefficient here is 1. Then for the base now, Cb is 0.1 mole per dm cube. Vb, the volume of the base is given, and that's 20 centimeter cube. So we have 20 centimeter cube. NB. Going back to the equation, that's the coefficient of the base, and the coefficient here, that is the number in front of the base, is 2. We have NB to be 2. Having done this, we have our CA, we have CB, VA remains unknown, VB is given, NA is known, and NB is known, and VA is still left unknown. So to get VA, we'll be making VA the subject of the formula. So here we say VA equals CBVB times NA divided by CA times NB. So let's substitute. CB 0.1 mole per dm cube times VB 20 centimeter cube multiplied by NA, which is 1, divided through by CA 0.5 mole per dm cube multiplied by NB, which is 2. So we have 2/1 centimeter cube, which is same as 2 centimeter cube. So we've gotten VA to be 2 centimeter cube. And going back to the question, we are being asked that what volume of 0.5 mole per dm cube tetrazosulfate 6 acid, that is H2SO4, will exactly neutralize 20 centimeter cube of 0.1 mole per dm cube sodium hydroxide solution, which is also NaOH. So from the calculation we just did now, we can say that 2 centimeter cube of 0.5 mole per dm cube H2SO4 will exactly neutralize 20 centimeter cube of 0.1 mole per dm cube NaOH solution. And that answers the question.